Hello, everybody. Here's a recording for 2016 FRQ number 1. This question here, let's kind of read through it real fast and talk about it. Water is pumped into a tank at a rate of this W of t function, liters per hour from 0 to 8, and t is measured in hours. Water is removed from the tank at the rate modeled by R of t in liters per hour. So now these are both rates. So remember, the derivative was already taken of these two items, W of t and R of t, because they are in liters per hour here. So that's important to kind of keep track of. Even though it's listed as W of t, it's really the derivative of something, but it's only listed as a W of t. R is differentiable and decreasing from 0 to 8. Selected R values are shown in above. So we have an actual function for W for the rate that water is being pumped into a tank. And for R of t, we don't really have a function, but we do have this information up here. So question 1, estimate R prime of 2. This is a classic table problem. So what I mean by that is they always give you a table, and they almost always start with asking you to find or estimate a derivative at 2. So since R of t is given in this table, R prime of 2 can be estimated right here between 1 and 3. So that's a slope problem, which are almost always the first kind of questions. So look at how these points are evaluated. 1 point is for the estimate. So you do have to have one of these two things. You do not have to simplify your fractions. So leaving it like this is perfectly fine. And you get negative 120. And then it also does say up here, indicate your units of measure. So to indicate your units of measure, if R of t is in liters per hour, then don't forget when you're doing a derivative, you're going to have to divide your y-axis units by your x-axis. So that would be liters per hour, or liters per hour squared. So that's how you get these 2 points. Quick comment on table questions. Table questions are often the highest scoring questions on the AP test in terms of FRQs. So for this, at this point in time, you're looking for points probably around 5 or 6 or higher for these types of questions. As we move on to part B. Part B says use a left Riemann sum with 4 subintervals indicated in the table to estimate the total amount of water used in the tank during the 8 hours. So water that was removed from the tank. So that's using this table right up here. Is it an overestimate or underestimate of the total amount of water removed? And then you obviously need to give a reason for why it's an overestimate or an underestimate. So with Riemann sums, that has to deal with increasing and decreasing, and I'll get to that in a moment. So here's your first left Riemann sum. It's not a terrible idea to make a quick little sketch of this. 0, 1340, 1, 1190, 3, 950, 6, 740, and 8, 700, and then this is, what is this, a right? Nope, this is a left. So left Riemann sum, you'll go over and down, over and down. So I usually like to spend the time doing that. Those of you that have really quick, good, and visual brains, you probably don't have to do that. But the left Riemann sum is anything that's given in these 2 steps here with a little bit of work. And then the estimate could be either one of these 2 answers. So once again, you do not have to simplify in Riemann sums. So you can leave it all like this. I find it often hard to delineate between these 2 points. So I'll give usually almost always those points together. Sometimes students will kind of write this out and do it correctly, but then they actually substitute in the wrong numbers, or they do accidentally a right Riemann sum instead of a left Riemann sum. So I think that that's kind of how they would give a point. So if they did an accidental R-RAM or a right Riemann sum, they wouldn't get that point, but they might get the estimate point because they're at least doing the Riemann sum. And then overestimate and underestimate. This is an overestimate because you have a decreasing function. So you do need to say the word decreasing to get the second point. That's the reason why it is in here, right here. It's in there because that's how you determine if a Riemann sum is an overestimate or an underestimate. Tangent lines, overestimates and underestimates, deal with concavity, but Riemann sums deal with increasing or decreasing. So that's your 3 points for this question. As we get to part C, use your answer from part B above, and even if it's wrong, you'll still get the same kind of credit if you do this correctly, to find an estimate for the total amount of water in the tank to the nearest liter at the end of 8 hours. So this one you have to be kind of careful with. So total estimate of water in the tank. Okay, at the end of 8 hours. So this 50,000 here, if we go back, no, we don't need to go back, it's in the problem. So 50,000 liters is the beginning amount of water in the tank. So that's like your initial condition there. So 50,000, and then you add that. This is IC. Sorry, I'm writing with a mouse, so it's kind of tricky to do this. So this is your initial condition plus your change in the amount of water. And then this part here, W of T, this is the amount that's being pumped into the tank. So that's how much you gain water. And then now you're using the estimate of how much is left. So that's where I go back to part B from. So if you don't have 80/50 here, let's say you did an RRAM instead of an LRAM, and you got this wrong answer, you're not going to get penalized twice. So if this answer or part of the answer here is incorrect, but you're still using the correct idea from part B, you'll still get both points here. So they view this, the graders, that the integral is one of the key moments in this. So making sure you understand that an integral for W of T gives you total amount of water pumped in. And you definitely need to have a 0 to 8 here because this is for those 8 hours. So just having that integral on your paper gives you that first point. The second point is actually the total. Now, of course, you don't have to simplify that. So if you left it all like this, that's fine. Or if you put it together, because this is a calculator problem. So I would honestly probably, if this was me, just do all these calculations since you can use a calculator. And by all means, please do not try to take this integral by hand. You can't really even do that by hand. You have to do this automatically here because there is no easy U substitution or anything like this to try to calculate the antiderivative. So this 7836.195325, that would have been done on a calculator. And I can put together other videos, or you could just Google them, how to do an integral on a calculator if you're stuck on any of that. But by all means, you absolutely should know how to do that. Moving on to part D. So part D, from 0 to 8, is there a time at which the rate, don't forget these are given rates, at which the water pumped into the tank is the same as the water being removed from the tank? Explain why or why not. Well, there's a lot going on here in terms of how you can kind of view all this. So first of all, probably most of you would do this. That's what I would do. I would just say, actually, no, I lied. It'd be this. So is equal to at the same rate. When are these two rates the same? This is probably what I would be thinking. When is W of T equal to R of T? Now, by all means, if you bring the R of T over, you could also have this alternative option too. W of T minus R of T equals 0. So you really need to be looking at this entire interval. So as long as you considered W of T minus R of T or this, that is the same thing. These two are the same. As long as you considered W of T minus R of T or W of T equals R of T, you're going to get this first point. But then the answer with the explanation here is going to be probably your most challenging part of this question. So you need to start here with your W of 0 minus R of 0. So R of 0 is 1340, and W of 0, if you plug a 0 in here, this is e to the 0, which is 1. 1 times 2,000 is 2,000. So if you go 2,000 water coming in minus 1340 rate of water coming out, you're going to get a positive number. Whereas if you do this with 8, and you can use your calculator to check that 8 here, plugging in the 8 here, and if you subtract those two amounts, you're going to get a negative answer. So I kind of put this into decimals because it's more clear to see than it is for a graphing calculator. But if you kind of take a look at this W of t function, which is this red one here, it does this. And the green one are just the dots. Now I connected them, but basically this W of t is above the R of t to the left of this intersection area. And then to the right, the R of t, or the table, is above that. So that's kind of where you could consider, are they equal? Well, one's higher than the other, and then they switch. That's when you consider the equalness of them. Or you could consider, probably a better way to do that is that at 0, you have positive. At 8, you'll have a negative when you subtract them. So the key here is you need to reference the intermediate value theorem. Why is this the intermediate value theorem? Because if you consider W of t minus R of t, and you want to know when that's 0, hence they're equal, then all you need to do is kind of show that it's positive in one area and negative in another area. That means that it's got to be 0 sometime in between. That kind of battles off both of those. Now, if you didn't reference the intermediate value theorem, but you summarized it correctly, what I mean by that is you have to say, since these are both continuous functions, and at 0, W minus R is positive, and at 8, W minus R is negative, therefore they must hit 0 somewhere in between 0 and 8. That is a good summary of the intermediate value theorem, but you need to reference continuity. Just by using the word IVT, that kind of overlaps the need to say the continuity part because it's assumed. Just a quick comment on that. Is there a time when? Explain if there is a time when this is possible. Things like that are always IVT or MVT. Since these are rates and you're being asked about rates, you're staying at the same level. Therefore, this is an IVT problem. When I say same level, it means IVT versus MVT, first derivative, second derivative, third derivative, etc. If this was not a rate and this was just water, and the same thing for R, this was just water, and they asked you about rates, then you're moving up a derivative, which is likely going to be MVT. But that doesn't apply. So hope that all makes sense. Thanks for listening. And here is FRQ 2016 number